Now this has to do with question 63 on 1-1, and we have to fold this piece of cardboard up into a box and then determine the volume of that box in terms of x. So let's do this. Let's run a fold along that dotted line, this dotted line, this dotted line, and this dotted line. And the length of this distance is x. And those are the dimensions of all of these corners. Now we're going to cut those corners out. And when we do that, we'll wind up with a piece of material that looks like this. And then when we fold the corners up, we'll actually have our box. And the dimensions, this distance will be 22 minus, and we've subtracted an x from this side and x from that side, minus 2x. And this distance will be 14, and by the same argument, minus 2x. We subtract the distance x and x from both ends. So consequently, the height of the box will be x. And I'm going to factor a 2 out of here, and I get 2 times 7 minus x. And factoring a 2 out of these terms, I get 2 times 11 minus x. So, this distance is 2 times 11 minus x. And this distance is 2 times 7 minus x. So the volume equals length times width times height, so which equals x times 2 times x, or excuse me, 11 minus x times 2 times 7 minus x. Now when we multiply these together, 2 times 2 is 4, and x is simply x, and then we get 11 minus x, 11 minus x times 7 minus x. And there's our function, volume as a function of x. But also, we now know that the domain of this thing is from 0 to 7. So the domain equals the set x such that zeros less than, as a matter of fact, less than x, which is less than 7. That is, to have a box, if we want to have a physical entity, then we could have an equal sign associated with those. Then we just have a sheet of material. Because if x is greater than 7, we'll get a negative length here, and that's nonsense. If x is less than 0, again, we'd have a negative height, and that's nonsense. So anyhow, there's our function, and we threw in the domain with it.